AC regulator. Okay, so most probably by this end of this week we'll complete this unit. Okay. In last class, okay, we have done like a different type of regulator. Okay, means single phase full wave AC regulator. Okay, then single phase half wave AC regulator, where we use all these calculations. Okay, you might, if you have observed, okay, this is almost similar to what we have been doing this. Okay, that positive half cycle, negative half cycle. Okay, it's conducting positive half cycle. One thyristor is conducting positive half cycle, thyristor 1 and thyristor 2 is conducting negative half cycle. Okay, then even if you see, okay, there is this conducts from alpha to pi and from pi plus alpha to 2 pi. Okay, if both the thyristors, if in case of a single phase full wave AC regulator. Okay, so this is the way, okay, we have been seeing. And even if you see this RMS value, okay, calculation of RMS value, you might see almost similar type of like questions are there. So I just want to request you once again, okay, please don't get mixed up with the formulas. I know, okay, there are so many formulas. Okay, it looks almost same. Okay, there might be a slight changes on the if you use a diet and rectifier. Okay, in case of a diet, is a control converter. So in case of a rectifier, it's a control converter. And in case of a diet is last time also during this first test assignment. Okay, I asked you to draw, I think it's by using a diet. Okay, most of you have drawn the SCR. So that is, I have been telling you, okay, these things that you don't get a. Please read the question carefully, whether it is mentioned as a diet or a rectif means a diet or a SCR. So you just get mixed up with these two things. Okay, and when you completely change the component used, okay, then the waveform or everything will be different. Because when you change this control converter or uncontrolled, in case of a diet is uncontrolled. Okay, but in case of SCR, okay, it's a control converter. So that is, you get mixed up with these two things. And there's no way, okay, that we can allocate certain marks for this, because you are using completely different component for this. And even the equations, waveform, everything will be different. So that's the difference between. So you have to be careful when you do this equations or anything. So all these things will have, you need to know the performance parameter of whatever we have been doing till now. Okay, the single phase full wave converter. Okay, if you know the formula, you just all these problems are just application of formula, and if you just press in a calculator, you will get the answer. So just to know the formulas. Okay, now what I'm thinking, that I'm not going in detail on these problems. Okay, thinking that you will go through these problems, and at least when you come back, okay, at least I feel that we can at least solve few of these problems during the face-to-face classes. At least try now itself. Okay, all these problems, I'll upload this. I think it's already there in the VLE. I'll upload. I think there are some modification on the PPT, so I'll upload the modified PPT. Okay, and please go through all these things, all these problems. Okay, if you just have to see the formulas only. So I think we have already done the different type of single phase AC regulator. Okay, there are different configurations can be used, like two thyristor AC regulators. Okay, two thyristor connection in anti-parallel. That is one method. Okay, two thyristor, two diode methods are there. Four diodes, one thyristor can be used. Okay, so in this case, in case of four diodes and one thyristor, okay, you don't require an isolation between the control and the power circuit in this case. So there are certain advantages as well as disadvantages using this different type of configurations actually. Now using a trike, okay, this is suitable for the low power application if you use the trike. So you know what is trike, okay, what is the function of what is the characteristic of a trike, okay, and these trikes and dikes, most of the time they use this combination of a trike and a dike. Today we'll see the single phase voltage controller with R load. This similar type of things we have seen in this kit. I'm just trying to give a detail on this, where in positive half cycle T1 will conduct from alpha to pi, and during a negative half cycle it will conduct from pi plus alpha to 2 pi. So this is the waveform. Okay, in this one, this is a source V, a source voltage. Okay, then this is a triggering of thyristor T1, IG1, the gate current for the, so it's triggered at an angle. Okay, firing angle at alpha. So this positive half cycle, during the positive half, it will conduct from alpha to pi T1, and T2 means T2 will conduct from pi plus alpha to 2 pi. So this is a point, okay, where thyristor T2 is conducting. So these portions, okay, from pi to pi plus alpha, this is alpha. Okay, this is a firing angle alpha. Okay, where we call as a delay angle. So we can have, okay, we can have a control over. This is also type of phase control, because we have a control over a waveform. Okay, where we can have at what angle are we going to trigger this ACR. Similarly, we can find out IOIS, okay, source voltage, and so BT1, okay, voltage across the thyristor T1, and voltage across the thyristor T2, okay, voltage drop across the thyristor T1 and T2. So this is a waveform for this single phase voltage regulator. So 0 to alpha, okay, the forward bias as shown in the waveform. Okay, then it will trigger T1 will be triggered, reverse bias with B1, and between alpha plus pi to 2 pi, T2 will conduct, okay, similar to this. So current circuit turn of time TC is equal to pi by omega second. So at what is the circuit turn of time? So single phase voltage controller with RL load. Okay, you have a load is RL. In previous case, it's just a R load. Okay, if you have a RL load, you know this, that waveform of the hyster current. Okay, gate pulses and input waveform. Okay, where this will go, the current will go beyond this pi. So it will not conduct only up to pi. So it goes beyond this pi, which is till beta. So these similar things, okay, if you have an inductive load, okay, we have seen in the previous cases also that the current will conduct beyond this pi. So this is a continuous gate signal, okay, where the pulse of signals are given, okay, number of pulses are given to a system. Okay, we call as a train of pulses to gate signals can be given, means that triggering pulses can be given to a system. So during the positive half cycle, T1 fired, okay, and carries the load current, and during the presence of the inductance in the circuit, the current would not fall to 0 at omega t equals to pi, which I have told you. So current will not fall to 0 if it has an inductive load. So it starts when input voltage starts to be negative. So T1 will continue to conduct until it current I1 equals to 0 at omega t equals to beta. So it will continue to conduct till beta. So the conduction angle, okay, we can find out del lambda is equals to beta minus alpha. This is the conduction angle, okay, we can find out in case of inductive load, because the current will not fall to 0 at omega t equals to pi. It goes beyond this point. So till point beta. So it will depend on the delay angle. So this conduction angle will depend on the delay angle, that is alpha. Okay, it will depend on what is the conduction angle. It depends on the firing angle and the power factor angle of the load. So these are the two things which conduction angle will depend on. So we can find out the RMS voltage, okay, from this. So BRMS is equal to BS1 by pi beta minus alpha, okay, where we can find out, and sine 2 alpha by 2 minus 2 sine 2 beta. It will depend on the alpha, means delay angle alpha. So this is similar thing when alpha is less than phi. Okay, if alpha is less than phi, in this case, okay, so if alpha is less than phi in this case, okay, the current is starting from negative point from the previous cycle. So it can continue to overlap towards, means another cycle of the waveform. So similarly, when alpha is greater than phi, okay, then we can have this. This is a firing gate circuit is when it triggers at the alpha. So this is where the source voltage output current, it will start from the negative point. So same thing, I think similar diagram we have seen this, and it doesn't fall to 0 at this point of pi. So it goes beyond this point, that's beta. So again, it's pi plus alpha to gamma, it goes to this point. So that is what is happening when alpha is greater than pi. So the gate signals of a thyristor could be short pulses for the control with resistive load. So it can be with the short pulses. And then short pulses is not suitable for inductive load. So this we cannot have, means it's not good if we have a short pulses. So why it is not suitable if you have a short pulses? When you fire the thyristor T2 at this point, okay, omega T equals to pi plus alpha. So T1 will still be conducting, because if you have a short pulses, okay, it means that T1 it's not completely means like T1 is not off. Still the T1 is keeps on conducting in the due to the presence of a load inductance. When the pulses are short pulses, when you have a short pulse, so it keeps on, in case of inductive load, it keeps on conducting. But actually, when T1 is off, okay, then only T2 should be on. So it should be alternative. But in case of inductive load, okay, that it overlaps actually. By the time current at T1 equals to 0, okay, T1 is off at beta equals to alpha plus delta. So at this time, when the time, okay, T1 is equals to 0, so T1 will be off. So T1 will be off only at beta equals to alpha plus delta. So there will be a given pulse for T2. So cannot be turned on. So, but in reality, okay, but in fact, in ideal cases, T1 should be off, then T2 should be on. But because of this nature of the load, okay, that T1 is not off at omega T equals to pi. So it keeps on conducting, okay, it is not equals to, it doesn't falls to 0. But it goes beyond this where beta is equals to alpha plus delta at this point. So these difficulties can be overcome by using the continuous gate signal. So if you use the continuous gate signals, then this problem of switching on of one thyristors and switching off of other, switching on and off mechanism can be controlled if you use a continuous gate signal. If you use a short pulses, then this disadvantage will be there. So as soon as the T1 equals to T2 would be turned on. So disadvantage of continuous gate pulses increase the switching losses of the thyristor. So if you use the continuous gate pulses, there are some disadvantages also. If you use continuous gate signal, there will be a switching losses of the thyristors and requires a larger isolation transformer for getting the signal. It requires means you require a larger transformer, isolating transformer for getting the signal. Now, why there is a switching? Because there should be a continuous pulse given to me. It means that the triggering has to be continuous. It means that there should be a continuous pulse. So in practice, train of pulses with a short duration as shown in figure 4 are normally used for overcome the above disadvantage. So usually they try to use a pulses with the short durations. Train of pulses of short duration. That I think it must be there somewhere. So this is a train of pulses of a short duration, means it should be like triggering should be in such a way that there should be a train of pulses, means of a short duration should be given to this. So it means continuously there should be a smaller means that of a short what it means that the duration, that the time period of this pulses should be so, it should be low. So it means that the pulses should be, the duration of pulse means like the width of the pulse should be short. So that's what it means to say. So we can give a continuous pulse signal, but the width of the pulse should be low. So these are the numericals. Please try to solve this. Okay, it's there in the textbook. Okay, the AC voltage controller is used for heating the resistive load of 5 ohm and the input voltage is 120 volt. So you have a voltage control, AC voltage controller having the resistive load of 5 ohm, purely resistive, and input voltage is 120 volt and 60 hertz. Thyristor switch on time is 125 cycle and off is 75 cycle. Okay, in the number of cycle on and off cycles are given. Okay, so you have to find out the RMS output voltage, input, same thing is there. Okay, so please try to see this, whatever problems are solved, problems are there, and please try to do this thing. I'll just upload this after this class. Okay, this PPT, I'll upload this and please try to solve this problem. So okay, this is the end of what we have here. Now we'll go to the cycle converter. We'll see what is cycle converter. Okay, then Do you have a calculator? How do we solve your problem? How many of you do not have a calculator? You might have taken the calculator from the college, right? How many of you don't have a calculator? Karagi calculator. The calculator may within there. I think it will be difficult for you to solve any problems. Okay. Now we never know when the college will reopen. The cases are everyday cases are increasing in India also.
Sir,
Now
they should train in the Zonomena, sir.
college not the Joseph. Now we don't have basic training in the colleges,
Yes, sir.
college and even in the schools. Okay, but the problem is now government is also not that much confident to open the schools and colleges, because if you see the scenario in other part of the world, okay, where they have opened the school, there was a mass that the increase of positive cases. There is a increase in the positive cases in some of the countries where they have opened the school, reopened the school, like especially in South Korea. In one school, one class, suddenly there was around, okay, as per the media report, okay, there in few classes there are more than 15 to 20 students who got the virus because though they have a SOP, okay, SOP, okay, but the problem is that the children, I know even in your cases, okay, as a mature student, okay, it will be really difficult to keep a physical distance, because when you come to the class, when you go to the dining hall, or even when you go to the room, you have a habit of visiting your friends, okay. Now if by chance if there is one cases in the colleges or in schools, there's high chances that everybody will get. So government is little bit like, I don't know how they will take the decision, but as per the report from Ministry of Health, okay, even the Ministry of Health is not confident to open soon. As per the report, I think they have written that it might take around 3 to 4 weeks at the earliest, but there is no specific date given. Though the basic training is not going on in our college, because next 40th and 41st is, I think they changed the venue. Just because we are asked to prepare just to reopen the colleges and school, but there is no directive from the government that we have to open on this particular date. So when you see the scenario, especially in India, okay, and it's like in West Bengal and Assam, okay, it is increasing sharply. Just nearby, like especially in West Bengal is now red, really is increasing. Even in Assam now, it will increase sharply because of this continuous rain. Okay, there is a fault in Assam. Now people have to be relocated in now. If there is one or two patients who is having the coronavirus in the places where they will be kept, maybe they might be kept in the one places only. So these things will never stop. I don't know when these vaccines and other medicines will be available, but what I see is that there is very less chances of like opening soon. I don't know, but it's just my view, okay. But government might take a decision that when to open, but it depends only depend on government. Even REB do not have authority to open the colleges. They might ask the suggestion, but ultimately the government will decide whether to open or not. And if you see in other countries, even in European countries, okay, when they have opened the schools and colleges, some of the universities they have declared that they are not going to open 2020 in some of the countries. They have already decided that they will go for online classes only. But we don't know. Now, RB has not decided. So when you see the scenario in other part of the world, it's really now India has came to the 10th position. Like now, it's on 10th now, as per the number of coronavirus cases, COVID cases. Now it's in 10th place. So because we solely depend on India, so the situation will depend on our country. Though we just have the people in quarantine only, the positive cases, even the positive cases keeps on increasing. So we never know when will when they are going to open the colleges or schools and colleges. So anyway, okay, we'll try to complete whatever we can do in this semester. Task force will decide either you will be promoted directly based on the online sessions or online classes, or you will have an examination. We never know. Like in some of the universities in India, like some of the IITs also, what they have decided is that they are going to promote based on the online classes. Okay, they are going to promote the students. So these decisions are taken in some of the like IITs, even in IITs in India, like IIT Kanpur, they have taken this, but RUB has not taken any decisions till now. So it depends on the RUB and the government that how do they decide. It will be uniform to all the colleges. If RUB decide that everybody will be promoted, then it will be promoted. And if they want the students to come back and do the examinations, then it will depend on that. So please prepare whatever is taught to you online. So stay okay. I think just okay. Let's complete this psychoconverter. Okay, then we'll. So this psychocon in last time also is okay. This is the converter. Okay, where is also a AC regulator. Okay, but in this case, it's a single stage converter where a fixed. There can be two type of fixed frequency can be converted to a variable frequency, and it can be a variable frequency can be converted into a fixed frequency. So especially this psychoconverter is a frequency changer. It means that frequency in some of the devices it requires it's operates on a different frequency level. So frequency changes that converts AC power to one input frequency to AC power of a different frequency. It means that it will change from one. So it can be a multi-stage converter also. Variable frequency output can be obtained by AC to DC again and from DC to AC using the phase control converter. We can use this is a two-stage frequency converter. It means that it's converting from AC to DC and from again DC to AC. It's a two-stage conversion, but in psychoconverter is a single stage frequency conversion. So in a single stage, okay, there will be a fixed the amplitude will be constant, but the frequency can be changed. So it can be a fixed frequency to a variable frequency, or it can be from variable frequency to a fixed frequency. So in case of first one, that one is a conversion of variable frequency to fixed, especially this from variable frequency to fixed frequency. It is used in the aircraft, especially wind generators or shipboard power supplies. So these are especially used for aircraft or a ship. So where the variable frequency is converted to a fixed one. So other one is from the fixed frequency to a variable one. So like AC motor speed control, even speed control of a motor can be. This is example where the fixed frequency is converted to a variable one. So it's a step. It can be a psychoconverter can be step up or step down. So for the efficient operation, psychoconverters are usually operated in the frequency range of 0 to less than 1/3 of the source frequency. So for the efficient operation, it will operate at 0 to less than 1/3 of the source frequency. So how does it operate? There are two groups. Okay, one is positive groups and a negative group. So it will form a two groups of rectifier will be there. So one rectifier, one forming a positive group and other negative group feeding a common resistive load. So when you have this is a okay diagram. Okay, you have a positive group and negative group. So it will be converted to it will have a two group. One is known as a positive group and other one is known as a negative group. It will feed to the common resistive load. So this is the common resistive load. It will feed to the common resistive load. It will have a two group, positive group and negative group. And it consists of alternative positive and negative half waves of frequency f. So it will have a positive and negative half wave of frequency f, and number will be as from 1 to 8. So this can be number can be from 1 to 8. It depends positive and negative. It can be more than this also. Just for as an example, okay, positive group allow all the positive half wave to pass through. So it means that it will allow all the positive half wave to pass through and also convert the negative half also. So it will allow to pass through all the positive half, as well as it will even convert the negative half into positive waves. So the firing is such that the half wave will be 1, 2, 5, 6, So it will pass it through it. Means it will pass, it can pass through all the positive halves, and also it can convert the negative half into a positive wave. So it that the firing will be means 1, 2, 5, 6. So negative group will allow all the negative half to pass through. So it means that there will be two groups, one positive and no negative. It will positive group will allow all the positive half to pass through, and even it will convert to means the negative half into positive half. In the negative half, it will allow to pass through all the negative half, and also it will be allowed to convert the positive half also. So waveform in the negative will be 3, 4, 7, 8. It will pass through this. The configuration can give any output having the frequency which is submultiple of the input frequency. That is, say what f by 3. So if submultiple of f by 3 will be 1, 2, and 3. So we'll pass it through the positive group. So submultiple of 1, 2, and 3. This is the input. Okay, submultiple of. So it can pass through one. It can pass through. I think this is the example. So it can pass through 1, 2, and 3. If it's a submultiple of f by 3 means it positive half group will pass through 1, 2, and 3 if it's submultiple of this. So and the negative half group, the half with 4, 5, 6 will pass through the negative group. So firing angle of a thyristor in the two groups are arranged to achieve this. So the firing angle will be means like arranged to achieve this, the positive group and negative group. So output waves are not sinusoidal in these cases. So but have an appreciable harmonic contents. So it contains harmonic because we're dealing with the AC. So it will have a harmonics. So this can be any number can be a positive and it can be negative. It depends on that and the frequency level. Okay, what should be the base? If it's f by 3, 1, 1, 2, 3 will be in positive half group, and 4, 5, 6 will be in a negative half group. If it is f by 2, then 1 and 2, okay, 3 and 4 will be in a negative group. So this is a single phase cycle converter using the center tape transformer. We can use the single phase cycle converter using a center tape transformer. So you have a center tape transformer, and inductive load is also there. So there is a function of this inductive loads. So during the positive half cycle, T1 and T2 will conduct, and during the negative half cycle, T3 and T4 will conduct. So T1 for the positive group, T1 and T2 is for the positive group, produce the positive half wave, and T3 is for the negative group. So it will produce the negative half. So during the positive half load flows through the load resistive R from point C to O. It will flow from C to O. During the negative group, it will flow from O to C. So why this inductor is used? This is to limit the short circuit current. So this inductor is used mainly to limit the short circuit current. So harmonics in the output can be reduced by adjusting the firing angle of the thyristor. So how if you want to reduce the harmonics, then we have to adjust the firing angle of this thyristor, 4 different thyristors. T1 and T2 is used for the positive halves, means positive group, and T3 and T4 is used for the negative group. So firing angle can be adjusted to reduce the harmonics. So this is when f by 3. So 1, 2, 3 is in the positive group, and 4, 5, 6 is negative group if the frequency is f by 3. So what is the difference between these two, between the dual converter and cycle converter? So you can just go through this. There are all dual converter can be operated in all the 4 quadrants. Okay, and dual converters from AC to DC and DC to AC, where cycle converter will convert AC to of one frequency to from AC to another frequency. So you can just go through this. Okay. So I think I'll stop here. Okay, next class in Friday. I think most probably I'll try to complete your whatever we have in our syllabus. Okay, in Friday. So after that, I'll just inform you what we'll do next. Okay. Either we'll try to see some of the numericals, or I'll inform you on Friday. Okay, Friday we just have 2 topics. One is UPS, uninterrupted power supply, and SMP, switch mode power supply. These two topics we'll cover in next class. So with this, I'll stop here. Okay. So do you have anything to say? So how is here? It must be raining, right, everywhere.
Yes, sir.
So as per the forecast, okay, it's almost now week out here in Devang. It's continuously raining. I don't know in other places. What I heard is that in other places also it's continuously raining. So
Yes,
please
sir.
stay
Unstoppable rain, no, sir. Continue.
continuous raining. Gatima.
Penciling, no, sir. That was the Nimshano, sir. Tama Daro Lok Chapter, sir. Continue.
Continuous whole night, day and night, continuous rain. Now it become foggy outside. Raining also. Light rain with fog. It's really horrible. So please stay safe, okay, and keep on learning, okay. So that I know, okay, it's quite difficult to learn in online classes, but please help yourself, okay, at least so that when you come back, okay, you'll not face problems. Okay, please go through the whatever PPT you have or whatever lessons you have, and okay. So with this, please stay safe. I'll stop here.